All right, so today we're going to be discussing mixtures. So these notes, make sure you take thorough notes in your notebook so that you can reference to them for your homework as well as for the lab today. Okay. All right, so we're going to define what a mixture is. So if you look at this picture right here, basically the mixture is a combination of two or more pure substances that are not chemically combined. They can be physically separated. So we can separate the oranges, we can separate the reds, we can separate the purple and the yellow. Okay, so we can separate them out because they're not chemically combined. So if we put them all in a bucket and then boom, we can separate them out. Okay, so we can also put them back together with their colors. Okay, so that's what a mixture is. So they can physically be separated, not chemically. So we have two main categories of what a mixture is. The first one we're going to talk about is a homogeneous. And this is when the molecules that are mixed together in an even distribution. Okay, so if you can see these three different sodas. We have a Mountain Dew, we have our Pepsi, and we have our orange soda. So if the Mountain Dew is going to have a limey flavor, and it's going to have that flavor from top to bottom, left to right, throughout the entire bottle. Okay. Same thing for the Pepsi. Same thing for the orange soda. It's going to be the same throughout. So you can give that as your homogeneous mixture. All right. So with the homogeneous mixture, we have a solution. All right, and a solution is an example of that homogeneous mixture. All right, so homogeneous mixture, we have a solution that's an example of that. So you just saw another example on the previous slide, but now we have a solution. It's a type of mixture that is the same throughout. And there's two different characteristics of a solution. It can be physically separated, and all portions of a solution have the same properties. Okay, so if you look at this Kool-Aid, we have the same properties: the color, the consistency, and the flavors, all from top to bottom, left to right. So we have the solution also has two parts. All right, it has a solute and a solvent. Okay, all right, so a solute is a substance that is dissolved to make a solution. Okay, and then you have, so for example, the Kool-Aid packet here is the solute. The Kool-Aid packet is our solute, and the solvent is what dissolves the solute. So we know the solvent is the water. Okay, so this goes back to what we discussed last year when we talked about the water cycle and the water properties. We're also going to be talking about it this year again towards the spring semester. But when we're talking about the water, just remember that it's the most common solvent, and it is very universal. Okay, so water is going to be friendly with a lot of stuff. It's going to get along with sugars. It's going to get along with salt. It's going to get along with even hot cocoa. So to make hot cocoa, you have that hot water and you have your cocoa packet, the powder. You mix it together, you stir it all up, bam, you got your hot cocoa. Okay, so remember, water is the most common and it's essential, and most things do bond with it. Okay. All right, so how is a solution formed? So a solution is formed, it's a combination of a solute and a solvent. Okay, so and the solute dissolves into an individual particles, and in a solvent, so it isn't possible to identify the particles separately. All right, it isn't impossible. So some of you may say, wait, you can't wait a minute, you can't change the color. You can see the color of the Kool-Aid, but that has nothing to do with it being able to see the little particles in our pitcher or our cup throughout the Kool-Aid. So if you think about the same thing with Kool-Aid, and you put less water in it, you will see those clumps of Kool-Aid. But if you put the required amount of water and you stir it up, that Kool-Aid will dissolve. All right. So the solvent is the substance that is present in the greatest amount. Okay. So understand that there's going to be other solutions. So if you're stuck on your EOG and with a question and talking about solutions, if you're giving an amount, that number, that's the one that has the greatest amount. That is going to be your solvent. Okay, that is going to be your solvent. So some examples of solutions, we have oxygen that has gas and it's dissolved in salt water. So, fish are going to be in the colder part of water. They're not going to be in the warmer part. So that is where that gas is going to get dissolved because fish need oxygen to live. So air is oxygen dissolved in nitrogen. Another example of a solution are bronze. It consists of tin dissolved in copper. You have carbon dioxide gas dissolved in soda. And then you have vinegar and acetic acid that's in water. That's a liquid solution. So these are all different kinds that will be on the EOG possibly, and they will give you the number percentage. And the largest, remember, is going to be the solvent. The less number will be the solute. Okay. So what changes the physical properties of the solvent when it is in a solution? Well, the solute changes the physical properties of the solvent in a solution. Okay, so if I gave you water and I told you to drink it, and then I gave you another glass of water, but I added sugar in it, you're going to taste it and say something's not right. Well, with that water, you can always change the flavor because the sugar has now become one with the water, and the sugar has dissolved. Now, this is a physical property. We can take that sugar out. It is possible but when we take the sugar out, it will change the initial properties of that water. So sugar dissolved in water has a different property from just water. Okay. So what do you mean by concentration? So concentration is the amount of solute being dissolved, and it has a particular temperature. That's one thing I want you to remember is the temperature. Okay. Temperature is our clue. All right. So solutions with higher concentrations contain more solute. So with higher concentrations, that is considered concentrated. So if we had a 500 milliliter beaker of water, and I initially put 10 grams of salt in there, and then I changed the amount of water and put 250 milliliters of water, but we still have the same amount of 10 grams of salt. Now that solution is now more concentrated. It is now more concentrated. Same thing with Kool-Aid. And if I didn't follow the package directions and I cut the water in half and you mixed it together, it's going to be very cherry tasting. And that's that concentrated part. Okay. So then you have solutions with lower concentration contain less solute, like salt water, and that's going to be diluted. Okay. That's the term of being diluted. So if you take Kool-Aid and we double the water instead of following the directions, and then when you taste it, you can taste a little bit of that cherry or the strawberry grape flavor, but you have more water in there, that Kool-Aid is now diluted. Okay. All right, so what does it mean by being saturated? So it contains the maximum amount of solute, our sugar, for example, that can be dissolved in our solvent, which is our tea. All right, so sweet tea, the solution, the solvent, the water is going to be able to hold as much sugar. And so you can keep pouring sugar is going to be at a point where the water cannot hold much more sugar and in that saturation. So it can hold the maximum amount of sugar. It has a maximum that it can hold, okay? So what does it mean by supersaturated? A supersaturated solution contains more dissolved solute than normal, and it possibly through the increase of temperature, okay? So the difference is temperature between a supersaturated solution and a saturated solution. So if you were able to add more sugar because the temperature is high and it will give you more of a super sweet taste like Bojangles tea. They're going to put sugar in it when it's warm because they can add more sugar because it's going to that's going to be the maximum that the water can hold. It's going to increase that maximum possibility of the sugar connecting to the water molecules, and that gives it a super sweet taste. But if you add the sugar if it's cold, it won't be as super sweet. It's going to have a less of a maximum that the sugar can be absorbed with that water. Okay. So solubility. Oh, so here's the tea as well. So the sweet tea. So solubility, a measure of how much substance that can be dissolved in a certain amount of solvent at a certain temperature. Okay, so when we can measure the amount of substance, so that's the amount of sugar that can be dissolved in water at a certain temperature. So that's what the factors are. Okay, so the factors of temperature. The temperature increases the solubility of solids and it decreases solubility of gases. Okay, so think about if you're in the ocean and you see the fish again, like we were talking about before, and they're in the cold part, not in the hot part, because that gas, the oxygen, can't dissolve, and then the fish will not be able to breathe. Okay, so the decrease in temperature. The decrease in temperature, it decreases the solubility of solids and increases solubility of gases. Okay. All right, so pressure as well. Pressure increased or decreases the pressure has no effect on the solubility of solids. Has no effect of the increase or decrease of pressure. Increased pressure increases solubility of gases. That's decreased pressure decreases the solubility of gases. So increased pressure increases solubility. Decreased pressure decreases solubility of the gases. Okay. So we talked about homogeneous, and now there's a heterogeneous, and that is when molecules are not mixed up in an even distribution. M&Ms, for example, we see colors. Okay, it's not evenly mixed up. We see the colors, point blank. Okay. So suspension. So with heterogeneous, the example would be suspension. And that occurs when particles are larger than those found in a solution. This snow globe, we see these particles. We can shake it up as much as we can, but we're still going to see those particles of flakes floating around in the water. So the particle size is larger than in a solution. It can't be filtered out. So, okay? All right? So I hope that you have understood the difference between a solution, the solvent, a solute, and a homogeneous and a heterogeneous mixture. If you have any questions, please let me know. Make sure you take thorough notes, and you're going to have a notes quiz to follow, and make sure that you can follow along when you do your lab. All right, thanks.